call me Sasha or Alex if you want to reach out. I have been working with Perplexity for almost a year and a half, and before that I was part of Yandex. So what I'm going to talk about, AI agents, LLMs, and since I'm working in Perplexity, a company that specifies on long-running stuff and specifies on agents that actually do and execute some work. But before that, I want to tell you a story. So before I joined Yandex or all other places working in IT, I moved to Serbia, to Belgrade, where I currently live. And I met my current best friend, but at the time it was a guy who was looking for a roommate. And he was working in the self-driving cars, in the autonomous vehicles. And he introduced me into the concept of vehicle autonomy. And when I was thinking about introduction to this talk, I was thinking to the idea of how to measure, how to experience the level of agents' autonomy that are executing and improving our life day to day. So what I want to start my talk is to introduce the level of agents' autonomy. So for example, the simplest level 1, level 0, is the life before ChatGPT was announced. We all, as developers, as a part of IT industry, we were doing everything by hand. What it means, like, we were writing the code, we were testing the code, we were searching, researching, going to the Stack Overflows, and reading the documentation by ourselves. But then LLM occurred. It was 2021 that it reached the public usage, and at that time, it was mostly like a completion. You ask a question, you get a response. For example, you explain to the model what's the SQL base that you have, produce me some SQL input, you execute the code, you're still the owner. Then cursor dropped, and suddenly we all go pressing yes for accept or D for decline into the changes, and now we're still owning the code and still owning the changes that we're making, but LLM now is much more around us. It's very near. The third level occurred when the, I would say, Cloud Code or Codex introduced goal approach. When you don't actually bother a lot with stuff that you're building right now, you just state what is the final result, what is the definition of done, and then you allow the model to execute in the loop until it's done and until it's verified. This is what Karpati and guys are explaining as an agent loop or research loop. The fourth one, which I think is the new frontier right now, is the autonomous operator. Imagine an LLM that, or some system, don't throw the LLM word yet, that observes your logs. And once the error log occur, the autonomous operator know how to research, where to look, and what to fix evenly. And the result of that is even like pull request, or in the best scenario, it will automatically push and deploy the fix. But there are one more step about that. Like, this one is coming. I've literally saw this stuff working, and I'm working on that right now. So yeah, this is here. And the fifth level, which is, I think, like the most frontier and most, I would say, sci-fi stuff, is the analogy to full autonomous driving. When you press the button and you get to the location without any experience on where to drive, where to turn, or how to bother with the crossroads. And what I think here, it would be something of autonomous organization, where you given the system, an orchestrator, a goal. For example, give me 1 million subscribers on YouTube. And it will spawn the agents that will research the market. It will do a lot of things related to actually delivering the goal. So it's going to be very high level. Imagine like you're a CEO. My honest opinion that right now we're all somewhere around between level 2, level 3, and level 4. Some of us between level 3 and 2. I hope I can consider myself somewhere between L3 and L4. And I recently interviewed a guy who is definitely on L4 and building the L5 stuff right now, which is very interesting because when I was talking to him, he does not reason a lot about the intelligence of the models. He doesn't bother a lot with Fable 5 or GPT 5.6 Sol. He says that all the stuff that we need to do right now is actually organized in proper loops with proper guardrails. And this is what I'm going to talk today. So my plan for you today to explain the vocabulary, what is the LLM, what's the agent loop, how I think those LLMs are going to work with tools, and what is the next step and the evolution of the tools to build this L3, L4 agents. Second, I'm going to talk more and deep dive into some architectural decision that we made during this agentic stuff, agentic revolution, and this is the sandboxing, the giving environments to the agents. And the third one, I'll take you into the infrastructure world where I describe why durable infrastructure and being able to create a system and architecture and design a system that can work for hours and days is very important right now. So let me start with vocabulary. What is the LLM, in my opinion? It's just a system, this very smart system, a guessing game, T9 after completion stuff. You give it some input tokens, and in the end, you get some output tokens. Very simple. But how do we get from this into stuff that can call me an Uber and can order me a meal depending on my dietary restrictions? You need to introduce a contract with an LLM. Basically, you ask an LLM to, with some tokens as input, to produce a structured output. This structured output I will view as a tool call. And basically, this JSON is the way of LLM nowadays are interacting with existing tools. So, for example, imagine I give an LLM tool that is search, and for that search, I ask you how to get to PyCon to Armenia from Belgrade. It will definitely research first what is the PyCon when it's happening. So yeah, it will definitely need to do something. Then you can make a loop. What does it mean? It means that you can build the abstraction layer above this that looks at these JSONs and executes them. For example, here we have a name web search, and you have some runtime that calls an actual search and then puts that search results back to the input tokens and loop until it produces the viable input. Then, well, this is good. This is basically what research is, deep research is, and how all the models nowadays are working with the search. Let's give it more tools. So I don't want an agent that I ask a question and it runs for 5-10 minutes and gives me some short or long description on what is the research or how to get to Armenia. Like go to booking.com, go to flights or Turkish Airlines. I want an actual executable work. I don't want to do a repeatable stuff. I want to be able to delegate an agent to book me a flight. Of course, with guardrails, human in the loop, but still, it should be an agent who is owning the loop. This is why. This is where I put the distinguish between L2 and L4 autonomous agents. So imagine, let's ask LLM to, I don't know, figure out the finance strategy for me. Then figure out the flights. It needs to figure out where to route, where is going to be layovers. Then, in the meantime, I want to spin up agent that is handling on my email, all my calendars. Then I'm starting to build a more and more sophisticated agent, giving it Slack, GitHub, Jira, all different tools. And now you find yourself in a position where you have a bunch of tools. Those tools are 80% of the input because your question is only about travel to Armenia or some search. But at the same time, LLM has an access to all this stuff that it will never use during this run, which is very wasteful use of tokens. But at the same time, you can view it as a, let's go back, let's step back. Let's view an LLM as a, let's ask it to research something. You still want to have a very good research. But at the same time, you introduced a bunch of tools that are like a screaming children in the room where you're trying to figure out something in the library, right? And each time, each loop, each step of the loop, LLM needs to decide which tool to use. And in this case, if you need only search tool, all the rest stuff is just the noise that you're paying for, not only with equality, but also with the tokens. And the obvious thing would be just don't give it the tools, right? You have a search question. Why do you need to give it the financing or flights or calendar? But then once we start to view our agents as smarter and smarter, we are starting to give them more complicated work. For example, I want to find out, I'm building a startup. I want to find companies that satisfy some sort of requirements. I want to check if they have any money. I want to check if founders are some guys that can reach out. I want to verify that sources. I want to verify the work, like compare different sources, SEC filings or something else. And then I want to draft an email to outreach each of them and making them personalized, not like a blank username. And in this case, you need to build a classifier that checks like 5 different blocks. It can be layered classifiers, of course, but in the end, it's just different things that you will need to include in your system and make it harder and harder. For example, you're including a new tool. Do you need to build a new classifier? Why? And what if this tool is something new that you don't have any data? Building classifiers are hard. So instead of giving a language to model or giving a menu of what it can do, I propose to give it a language. So what I'm saying in the menu and language means like, imagine you are an LM model entering the restaurant where you want to eat. And you present it with a lot of very long list of options that you can choose of. For me, it's always confusing, like what I should be eating today in the Armenia, for example. But instead of that, I can communicate with this menu. And I can introduce some language to talk with waiter who is coming to help me. Like, today I'm in a salad mood, in a fresh, fruity stuff. And analogy for that, for the LLMs would be, instead of tools, let's give it an environment and a code execution to actually research environment that it lives into and produce a deterministic code that will run those commands and get you the result. So this is not some theory that I was theorizing a lot. It's not something that I imagined yesterday. That is what actually a lot of companies are doing right now. For example, there are 4 of them that I presented on the slide that I'm aware of. And a lot of companies right now move from giving MCP tools or tools directly to the code execution with CLIs or SDKs. Even I think when I was flying here, I recently discovered that yesterday Notion introduced their CLI and SDK in Python to communicate with the documents that you have in the Notion, instead of MCP that they had a year ago, which is already very powerful. So, and of course, the place where I'm working right now, we're extremely focused on the search and deep research and wide research. So this is the improvements that search as a code approach and search as a code approach where you give it a ability to write code on how it wants to be searched, brings a lot of improvements. I think the top ones, GSKA and Browse, Comp, HLA, and Wide Search are not very interesting, but inside the Perplexity, we build an internal wide and deep research that we call Wonder. And this is the task where you need to research and find companies in a wide range. Like I think the most interesting example would be find all ex-Googlers who went into stealth mode to the startup and give me a list of what we're doing. Give me at least 1,000 examples. So there we observe significant improvement. It's like almost twice as for this value is I think outdated now. So how did we do that? First of all, as I told you before, we need to give it a language. The most common language for the models right now are either JavaScript or Python. So we build a Python SDK for our search. This Python SDK splits the commodity search, which is, I'm sorry, I didn't introduce this slide, but basically traditional search is retrieval, deduplication, ranking, deduplication, filtering, and then final 10 or 15 links that you see on Yandex or Google. Instead of that, if you're doing 1,000 companies research, I don't want to do any ranking right now. I want to do it in the very end. Or, for example, I don't want to filter something. I want to filter in the very end. But also at the same time, I want to embed these results to be able to do a semantic search that I think someone was telling here in this room. So instead of that, we gave the model those primitives. We basically gave the model ability to write the commodity search pipeline from the scratch and configure and modify it so it achieves the results. So second one is to build that a skill, but not just a skill. It's a tree and nested skill, because if you're presented with sophisticated SDK, even humans or myself, first time I see a new framework, I'm scared. I don't understand how to do some simple stuff. And for that, I need some guidelines, some references, some common recipes to do some common search. So this is what skill is. And we build it in a, I would say, nested way, like a tree, where you have a common head, the first node that model always sees. And inside of that, we explain it, hey, LLM, Fable 5, you can go to do a wide research, please reference to this node, to this leaf. If you do want to do some financing or people research, please reference to this leaf. And this is like a nested structure of knowledge that we've built specially tailored for agent. Of course, it's a lot of markdown files and a lot of text, and it was never written by hand. It was made by after research. We had our benchmarks and we asked model to improve itself, which is thanks for Andrei Karpati to introducing that idea, and everyone is right now is running with that. So yeah, and the third one, I think, which is most interesting, once you give it ability to execute code, you need to actually like give it a place where to run it. It's not very easy task to give a model like some cloud that it can do anything right now. Like recently OpenAI DDoSed Higgsfield, right? We don't do that. We don't want that. So now I want to talk more about this home for the agents, as I call it. How did we build it? First of all, I want to give you a thought. Like when you're working locally with your instruments, like Codex, Cloud Code, or Open Code, or Hermes now, for me, it always feels much more powerful than going to ChatGPT or Cloud Code or Gemini.com. It feels like it's almost have much more stuff that it can actually execute. So, it is not only like that. It's because it has, it's not like, it's not only a feeling, it's actual reality. It has like your local running agents have a file system and have an environment where it can create some temporary files, temporary scripts, while external providers does not have that. So what we did, we made a space, sandbox especially for agent execution. And this space is basically a virtual machine or environment or Docker container, you can call it anywhere you want it, which give a model access to file system, some shell execution bash commands, some tools that we provided as an SDK or CLIs, and actually we give it ability to go to the raw internet, which is the first thing everyone that I shared with is the first I see in the eyes are they're scared, honestly scared. Like, why? This is the model. It's very smart. Everyone is scaring us that it will leave some environment and conquer the world. Well, actually, of course, we gave it very controlled limits. First of all, the files that exist on this virtual machine or sandbox, we don't care if they're leaked. What does it mean? It means that we either okay with sharing those files, even .env, or it was AI-generated files which we don't really bother sharing with anyone else. Second one, we don't give it, like I was referenced .env, we don't give it stateful secrets. It's not API tokens, it's not auth tokens. We build a proxy that means temporary stuff that lives only when agent loop is leaving. And on top of that, we have a sidecar that switches those tokens to actual ones to access external internet. And this is already a lot of infrastructural work. Second one, we did not allow it to go to the wild internet. We gave it only a set of network rules and domains and that it can actually access. And it means that, for example, if you ask to find the flight from Belgrade to Armenia, and you see that your model is trying to connect to bitcoin.com, something is not going right? And you want to drop that connection as soon as possible. So, and of course, we narrowed down the tools that can reach out this requirement, this environment. So this unblocked very important thing. Now, when model is researching something or generating some context, it can just, it does not require to store everything into the context anymore. Context is shrinking because instead of generating like 1,000 line markdown file, it can write it to the file system, save the notes file or reference to that file, and carry that file reference during the execution loop, which is, I don't have a number, but my gut feeling tells me that it saves you a lot of tokens, and thus it saves a lot of context and price as well, so dollars. The second one, we wanted to to give the model ability to research and to be able to reason within itself. So we did not just brought up the sandboxes on CLIs that are thrown up to the model and it just need to figure out each time what's going on. Actually, we prompted the model to always search for help before doing something. And this brought up some improvements. Basically, we gave it a very useful prerequisites on how to use each tool. Basically, it's like a skills, but embedded into the CLIs. So we ended up with something that I'm going to call harness, following on. I hope someone of you heard that word, but if it's first time, harness is basically in our harness that we have is model loop that I described previously on the first part. Second one, we limited the tools to work only with the sandbox environment, basically give it a language, not a menu. Then we give it an isolated sandbox. Each model loop gets different sandboxing if we don't have an idea to do it otherwise. And also we made a sandbox templates, which is basically saying that it's not an empty virtual machine, it's with some pre-existing stuff that we specifically tailored for this execution. And I wasn't honest with the work that I was doing here, or maybe not transparent, because all this deck was built by the agent itself. So I literally did not touch anything by hand. And it was done by the agent harness that I described before. It's the tools, skills, ability to generate JSON, from JSON generate some PDF files and presentation. And in the end, I hope you are seeing like a good picture that is not very AI sloppish, right? But the question here is how to make it reliable. Because as you can see here, I've spent almost 2 hours, not me, agent spent 2 hours, who basically saved me 2 hours of building this deck. Which means that this agent loop will probably outlive some restarts, deployments, crashes, failures, or let's look into different direction. It must outlive a lot of long research. It must outlive wrong choices that it made. It must outlive the errors that pollute the context. And what is the most important thing nowadays? It should not cost an infinite new Lamborghini amount of money, right? So the part 3 is where I talk more about the infrastructure, how it was built behind. And first of all, I want to start this part with the idea that in Yandex, I was working a lot in optimizing on finance stuff, and finance stuff is the place where you want to optimize milliseconds. It's like thousands of them, tens of them. Even sometimes I've seen the nanoseconds optimizations that brought actual value. But nowadays, in agent runs, they showed no one actually cares about like tens milliseconds, right? It matters when it's compounded, but in the end, you can wait 1 hour and a half or 1 hour and 15 minutes. So this 10 minutes gap does nothing for my life if I just delegated the work to the agent. I can just spend more time with a family. So there are 3, I think, hard problems to solve to enable this long-running stuff. The first one that I already touched is the context. Each step in the loop makes this context bigger and bigger. And imagine it's like thousands of steps. Even if each step brought you 1,000 tokens, in the end you will get like, what, millions of them? And they are resent to the model. Second one is the durability. As I explained before, like if it's hosted somewhere in a reasonable, not infinite pony world where there are actual machines, virtual machines, they are going to get crashed, they're going to get out of electricity, out of storage. We need to solve this. Second one, we need to be able to control this. Imagine that you launched the model, launched an agent, and then you understood, well, it is not working right. It's somewhere in the middle in the 30 minutes run. I need to stop it. I need to cancel it. And I need to be able to restart it from some breaking point. So, and it's not very easy to do once you have like 1,000 steps. Let's start with the context. As I said before, context is getting larger and larger each time, which means that step 1 produced some input and output tokens that are going to be resent to the second step, and so on. Which means that after 100 steps, the model seen tokens from step 1 100 times, which is always costing you money. So the first and obvious thing would be, let's introduce caching. Caching is the answer for everything. Models are extremely good in caching. Yes, this is true. And caching prices, this is not a secret, are less than actual input token pricing. But imagine it's 1,000 steps. That one of the 10s, like 50% discount, even on a scale of 1,000 steps, it's still half of input token price. It's a lot. And what's the most bothering here is that imagine you have a dead step in the middle. By dead step, I mean the wrong step, step with an error, step that produced a hotel that I personally don't like, and I forgot to tell a model about it, and I told it only in the very end. This one is going to be carried all the way through all caching. And you cannot just throw it away, because the caching in the models work that you have a prefix cache. It's not like each step is cached, you have a prefixed one. And if you're dropping out some step in the middle, you're canceling the cache. Well, no optimization's done. Nice. So instead of that, I propose to introduce the delegation process. It's the process when you give a task to find the hotel in Armenia to a separated agent that has its own context. In result, I don't need the whole steps from that agent. I only need the report and links and the most important things. This is what I'm saying as a delegation one. You have basically you have a context firewall. You have an orchestrator model that sends dispatches a subagent with isolated context, maybe even with isolated sandbox. It depends on what you want to design. Instead of burning like millions of tokens backwards in input, it just produced a few short summary with what is actually needed to be done. This is good. This works a lot. And I suggest, like, when you're coding, prompt your agents to delegate to subagents. It's provenly to be much better. I don't have numbers, but yeah, just trust me, right? But then you are in the state where you asked tens of subagents to do some work. And sometimes you even want to ask subagents to check for each other. And sometimes you want to give them a consensus. And each model in each subagent will produce an output that can have some duplicated context or polluted context or the context that you don't need anymore. For example, you ask the agent to discover the route through Istanbul or through Athens or through Dubai to get to the Armenia. But then you decided, okay, I will go with just Istanbul, it's too hard, just Istanbul. Then all those subagents who were discovering the Athens and Dubai are not relevant anymore. We need to discard them. And an idea to do that is the obvious one, just introduce the compaction to the context. The compaction and the process of compacting worth, I think, 1 hour speech on their own. It's very complicated thing to do. And the people who are doing, like companies who are doing the compaction focused research, they're like brilliant guys who are pushing the frontiers. And what I want to say here is that once you have a file system and a sandbox, compaction becomes much easier. Because instead of erasing all the context, you can always say to the model, hey, I saved previous conversations somewhere on the file system. If you feel like you are forgetting something or you need to rediscover some stuff, just grab it from previous context. It's not there, but you can reload it. And the persistent file system allows you to do that. Of course, there are much more to do. Sometimes you want to discard that research or don't even like choose that, or maybe redo some stuff. So, as I said, it's worth a completely different talk. And if you're interested, Anthropic has an amazing article about that. What I want to focus instead, on the infrastructure part, as I promised to you, right? As I said, worker is going to be killed. You're going to get rollouts. And what I recently discovered in my personal experience, clients are going to get disconnected, you're going to have networking problems, and your agent loop needs to outlive all these processes of your clients, processes of your pods, or processes of your rollouts. And to do that, I propose to view this as a distributed system. And we all, a lot of guys who are working in infrastructure are very good in distributed systems. And I propose to view this not as an agent loop that runs on the same machine. I propose it to view as a worker that executes the step. And to do that, you can just introduce a basic architectural decisions like a queue that handles what needs to be done, the worker that actually executes the step and runs it, and the event storage that where you have basically a dump of current state. And I want to focus more on this event storage. Why? Because in my personal experience, in my opinion, I think that how steps and agent loop is organized is the by-the-book design of event sourcing systems, like the ones that were written like 10 years ago. Why? Because each step is basically stateless. It has a previous input. It has a new differentiator that modifies the state, but it is append only. And you can ask the model to and view the result of the model as a new event that you dispatch to some event system or event store, and then you just save it as events or steps. What this actually buys you? It buys you an event log, which is basically you can always roll back to different steps and have the same state that was there on like third step while you're already on sixth one. You have a cursor. If your client disconnected on step 5 and you're already on step 15, it can also share with you the ID of identification of previous event that it acquired, and then you can just replay it from the state. Also, it brings you the ability to have a forkable sessions. Imagine this is not for production usage, but imagine you're training a model and you are wondering, well, here model decided to write this code. But wait, what if this code was different? In that time, you can introduce the tree of decisions. And on each decision that seems not very reasonable, you can replay and start with new checkpoint of the model. This buys you a tree. I would say nested tree structure. Oh, sorry. How do I get back? Yep, thanks. So yeah, and of course it buys you an ability to kill your workers. If your worker is dead, you just attach it to a latest step that was committed and you just go on. So what I want to focus on and what is my summary, like 3 main bullet points that I hope you will remember is that code is much better than tools. Models nowadays do code writing and code execution much better than tool calling. And for tool calling, you can give a model a sandboxes and environments and place where it can actually run something. And to be able to successfully execute that long-running sandboxes with a lot of code, with a lot of steps, you need to build a durable infrastructure. And in my honest opinion, last 20 years, I'm 26, but yeah, all backend development, all infrastructure guys were optimizing for the systems that live for milliseconds. It was asynchronous stuff that you need to optimize like hot paths. But next decade, our client is not going to be a person or an agent who cares about the milliseconds. It will be some process that lives for hours and reasons about it. So my honest opinion that nowadays is the best time to be infrastructure engineer. So this is where I conclude my speech. So yeah, any questions?
Thank you. Do you have any questions?
Yeah, my question is, why do you think the agents prefer the bash and like sandbox environment? Why is it the best habitat for them instead of like something else that maybe we haven't come up with yet?
I agree. And let me answer a different question and get back to you. I think this is the same reason why I think that Python is the best one, or JavaScript. And we unfortunately did not come up with a better language for agents right now, but I know Dercel is building something for someone else. And the reason for that is that there are just much more Python in the world, in the GitHub, than any other language. It is the most popular one. So the same is true for the environment and sandboxing execution, because bash is the most common one. Everyone doing some scripting, some stuff with a bash, not something else. But yeah, I hope we will see the time when we are having a specified language or specified execution scripts that in a language that were designed for LLMs first, not humans first.
Any other questions? Sure.
I have a small question related to the harness design. And it's a bit bigger one. Now everyone is designing a harness, like every company, at our company and everything. When do you think we can reach a unified practice for building this, given that everyone is experimenting and it's very, very early? But when do you think in general we can have a common practice on what's good, what's bad? Just as an idea, like what do you think from what you see when we can reach this kind of agreement on it?
This is an amazing question. I will also start with answering different one and come back to yours. I would say that I want to start with a story. 1 or 2 years ago, I was writing the code by hand, and Cloud Code was just introduced. And I was obviously thinking that, well, this stuff will never take away the feeling that I do when I actually write the code. It will never take away my work that I do manually. 2 years passed, 1.5 years passed. I don't write code anymore manually. I don't even look at the code probably. I just delegate it to goals within the loops that execute the goal in a loop. So what I want to say that I'm very cautious on bringing any timelines or giving any projections or something else. But regarding the harness, I think there are just an idea that everyone agrees on, that we need to start giving agents coding agents, giving it environments, but everyone implements its own, there are two options to that, two reasons to that, in my opinion. Is one is that everyone believes that this is their secret sauce, and there are like daily coming up with new startups who are building the same harness that everyone builds, but believe that they have a specific prompt or SDK. And the second answer would be, second reason would be, this is too fast of evolving field, and nowadays code is almost free, so it's very hard to build something unified and unique for everyone, but at the same time expect that everyone will adopt it, because everyone have already built their own. Mm-hmm. And why do I need to migrate to something else if it does not bring me any much of features or improvements? And yeah, and since the code is almost free, I can always rebuild it from scratch and have more control.
Okay, another question related to this and also to the, let's say, standardization part. Why do we need to build tools or like ways for the LLMs to access tools or configuration and so that are LLM, like more LLM oriented than having something that coexists for both of us, like the agents and the humans? I think having something like Bash or the CLI, but more improved is better. But I want to understand, like, is the reason for this like more optimized, let's say, token usage, better hardware usage, and so on, or maybe better OS integration? So what do you think?
If I understood your question correctly, you're asking about like why do we need to build some specific for agent stuff and not for something in the middle where humans can actually use it. My honest opinion, which is very speculative, it's not like a company's position or whatever. And my own like personal opinion is that I want to live in a world where I just delegate to agents and focus on something else which I need to figure out. But yeah, I think it brings back to the first slides that I have in my presentation, which is if we're aiming to get to the L5, which is autonomous organizations, and where you just ask it to do something and it's private, your personal assistant or whatever, sometime in the future, I would say like almost sure that we will see where the tools that we give to the model and how they're designed is the bottleneck. Now it's not. It was trained on Python, it was trained on Bash, it's okay. And now we're squeezing the harness, now it's squeezing infrastructure, now we're squeezing how we aggregate all these blocks together. But we eventually will run into the state where we need to squeeze final percentages and final improvements. I don't think this will happen like before L5. I think once we reach L5, every company that reached L5 and selling the L5 state of orchestration will now get in the race where they are implementing this last squeezements of the improvements. I hope this answers.
Yes, thank you.
Any other questions?
Yeah, hi. Thank you for the talk. I have a question about expenses. Like, if we are talking from moving from caching approach to this approach where we have like an event queue, it feels like we have like more input tokens and more output tokens. Do you have any measurements like how much more expensive it gets, and is it reasonable to do it in terms of expenses?
You talk about this one, right?
Yeah. Like, if we always like cache something, like we write these like files that are like our memory, and we can read them. So we need to like produce output tokens what to write in this file, and then we need to read them, and so we like spend more tokens.
This is a fair one, but you can always just discard what you wrote from the input and don't carry it through the loop. You can just say, hey, look at this reference stuff, and of course you can do some cache manipulations here with we can talk outside later. But yeah, you are in control of this cached inputs, which means that it is not necessary to be the same as the output. You can transform it and save it, and then I think there is a second question in your question, which is about this approach where you have an events, and you need to make sure that this event log is replayable, which means that if you replay the steps, you will get the same input stuff, and this is easy to screw, of course. But you need to make sure that if you replay it step 0, 1, and 2 to different machine, it will get the same prefix. And yeah, this is infrastructure problem that we need basically to solve. This is a very important thing to keep in mind. And yeah, thank you for asking. It can bloat your expenses like 10 times.
Oh yeah, I can answer maybe last question.
Sure.
So given this utopian autonomous future that agents will run 24/7 and build software.
We're already there, but yeah.
Yes, we're already there. Oh, okay. So what people should build in this case, like given that it's very cheap and easy and yeah, you don't care about 10 minutes, half an hour, and you can delegate tasks. But what is the task? Like what would you create that will add additional value to the world?
I think it's an existential question, right? If agents can do everything, what I should do? I don't have an answer, but I think I can answer a different question one more time, which is what I will be building in the meantime unless we're in that loop. And the answer for that would be I'm designing the loops, I'm building the agents, and unfortunately, we're not yet in the state where I can draw the hockey design on the whiteboard, photo it, and share it with some agent executional stuff that can reiterate and change the architecture. It can change the ways that he thinks, but if there are some requirements and restrictions within the design, for example, it cannot deploy, I will still need to give it an ability to deploy or bring somewhere human in the loop, or bring up the advisor or observers agent. So yeah, this is what I'm actually like working on. I hope this answers.
Can I share a question? I have a question. Can I have a question?
Yeah, so related to this blurred part, like 20 years of optimizing infrastructure, right? So I think, in my humble opinion, 20 years of optimizing have enabled us to have next 20 years. And somehow I think that no one is going to be in content with hours working on something. So everyone is going to have, come on, man, why is an hour and a half? Like you have created this presentation for 1 hour and 40 minutes or whatever. So next time you're going to require this model or harness system to work in an hour and then 40 minutes and then 20 minutes. So I think that it's just another pool of optimizing things. So what's your opinion on that? I think it's endless actually.
Yeah.
So
I think I have a strong opinion on that. First of all, this is true. If I once saw the agent building good presentation in 2 hours, next time I'm expecting it to build it 1 hour, half an hour, 10 minutes, as soon as possible. But this is about the task that have definition of done or have an end. But if I have a agent or agent loop that was designed to continuously monitor my logs or whatever, I expect it to deliver the fixes as soon as possible, yes, but still I expect it to work 24 hours, non-stop. And I think that this atomic stuff that has definition of done, we as a people, as a human being of flesh, are no longer going to set the prompts or requirements to get this definition of done stuff. I hope we will get in a state where we give a model or high-level thing, like observe stuff or improve my revenue. And it will work non-stop, improving shareholders' value. But as a subset of this agent loop, it will have an agent, a worker, a bee that will execute this end-to-end thing. It will build a pitch book. Maybe it will even apply to the conference for me, and just ping me, hey, I've built your pitch book. Here's the summary stuff. Go talk about something human. So yeah. I don't think like what's the morality of that, how I feel about that. But from a technical perspective, as an engineer, I think like this is where we're heading. I hope this answers. Anything else? I think I'm out of time more.
No, you're not. If you have any questions, you can go. We have another 5 minutes. We can
True.
Maybe I have a question. So, Again, it's some existential one maybe. So, like based on this quote, right? You say that okay, it's a great time to be an infrastructure engineer. Probably it's a great time to learn basics, right? Like all these cube,
Yeah, design.
worker, etc. So that's a way how you should think about it. So this is the one approach.
Yep.
And then the second, like if everyone building harnesses, probably the best way to became better at building harnesses is start to build harness.
That's true.
But that's also true. But the thing is, when you start to build harness and automate, you not really learn. Kind of, it's difficult to learn old things like new way because you not really go deep. Like you not learn anything. You just try to delegate it to agents, so it do it instead of you. Like, what do you think? Like, what will be important? Like, be able to build your own harness or learn the basics so you can understand, and how you keep this balance between I actually need to understand and I can delegate it.
This is an amazing question. First of all, thank you. I think I already answered it in 2 months ago within some interview, and the answer now is different. Welcome to the world, guys. So I would say, first of all, I will quote a colleague of mine who is working with me: "Ride the wave." So feel if working with harnesses right now is the correct way of learning. But going back to learning and building harness, I think I will say something like this. Learn the basics. I think you don't need to worry that much about coding and actually delivering and writing the Python anymore, or whatever language you're using. I think it's more important to design systems, understand the complexity, and always think about how it will work, like on scale, or how it's, I would say, something agent extendable, right? When are you okay with just repeating code where an agent is going to get confused or not? It's more of a feeling. And to actually learn how to do that is to build, and you can start with something that you already understand. Imagine like you're an engineer or starting engineer or just graduated from STEM, from engineering or whatever university. And then you're in a place where you need to learn up-to-date skills. Take something that you actually worked on your article, on your final diploma or something, and try to build harness that can work with the stuff that you've worked. For example, I think the most simple thing is the observability part. A lot of interns in different places, not in where I'm working right now or where I work, but I've heard things that they are basically asked to fix the bugs from error codes from Sentry or whatever, and like make Sentry 0, right? Instead of that, ask them to build a harness that can actually observe this stuff. And then you will get the feeling, hey, actually here, model triggered correctly on the error, but did not reason well to find the solution. Why it did not reason well? Because it didn't have an access to code, or didn't have access to, I don't know, profile stuff if it's out of memory stuff, things. And then you start to plugging more, and then you find where you're yourself in a place where this plugging does not bring any value because model is too confused. Then you solve that problem well. So it's more of a, so TLDR, the short answer would be get some domain where you have enough knowledge to work on your own, then bring the harness as your intern or co-worker or teammate, and then just make sure that it works. So be a manager, basically.
Yeah. And you should be at least like have an expertise at the first step. Like you should be engaged. You should understand what's happening on the. Yeah.
And then the answer for that we already have. Like there are a lot of books. It's the same.
Thank you.
That's it. Thank you.